Alright, this is our review for our last summative here in PreCalc. This is a pretty quick review. I don't have a ton of time, so I'm going to skip over some calculator entry things. So if that's what you're looking for, you're going to have to go back and visit the lessons. Alright, so review of graphing systems to solve them. So you want to probably get these in slope-intercept form is the easiest way to graph them. You could either add the add the y and subtract the 8, or you could move the x and divide by a -1. Either way, you end up with 2x minus 8. And then for this equation, you're going to subtract 5x and divide by 5. So you're going to end up with -1x plus 4. And then you're going to carefully graph these. I know that's funny coming from me. And, yeah, oh boy, can't even draw. Okay, so pretend that connected. And then, let's see, starting at 4, down to 1 over 1. Alright, so I can see the intersection point, which is the important part. The point in which they intersect, which is the ordered pair 4, 0, is the solution to that system. X equals 4 and y equals 0, but please do write them as ordered pairs. Alright, the next question is a system of linear inequalities that you're going to be graphing. Be careful whether your boundary line is solid or dashed. This one's going to have a dashed line, and it starts up here at 5 with a slope of down to right 1. And you thought I graphed lines bad. That's got nothing on my dashed lines. That's even worse. And I'm not going to shade yet, but I'm supposed to be shading less than that line. So I'm going to kind of draw arrows indicating I would be shading underneath it. Now this line is not quite in slope-intercept form. You're going to add the 3x and divide by 2. None of that switches our sign from a greater than, though. You end up with 3/2 x minus 2. So starting at -2. And then slope of up 3, right 2. Doesn't really matter where they intersect, other than, you should be graphing semi-decent. And we're supposed to be graphing above that line. So now your job is to figure out where they intersected, and I can see that the boundary in which they intersect is here. Now please do be careful about that green line being dashed. Sometimes I forget, and I gotta go back and write my teacher a note that it was supposed to be dashed. Alright, they want you to use the elimination method here. It doesn't really matter which one you eliminate, but I like that the y's already have opposite signs, so I don't have to mess with those. So I'm going to multiply this top equation by a 4, and this bottom equation by a 3, which will knock out the y's. So our linear combination, our new system, is 8x plus 12y equals 36. And then, let's see, 9x minus 12y equals -87. Now these do come out pretty nice all the time, so keep that in mind. 17x equals a -51. So x equals -3. No, it does not, Abruzzo. Yeah, -3. There we go. Oh man, my key's wrong. Alright, let me fix my key real quick. Goodness gracious. Messing up right and left. Alright, here we go. So, moral of this story is if you drop your negative sign like I was about to do, you're going to be in trouble because when you go to find the next variable, you're using the wrong value for x, so be careful. So I'm going to go and plug in x equals -3 into this bottom equation. So that becomes -9 plus 4y equals -29. I don't know why I use that equation. Oh well. Add the 9 over, and you get 4y equals -20. So y is positive, or -5. Oh my gosh, I screwed up on my key again. How can I possibly mess this much up? Time out. You know what, maybe I shouldn't be recording. This was a -4y. Oi! Probably just lost half my viewers at this point. So dividing -20 by a -4, you get +5. Okay, your solution after all that struggle was -3, +5. Your PreCalc teacher shouldn't really have that much trouble with an Algebra 1 question. Oh well. Alright, this is the question I'm a little concerned about. So she's selling bows and bracelets. So let X stand for the number of bows. Make sure you have a very specific setup there. And Y would be the number of bracelets. I feel like I didn't spell that right, but oh well. Oh yeah, I did. Now this first equation is all about the money. So it's $4 per bow plus $5 per bracelet, and she sold $100. But this last equation is the one I'm worried about. She sold 5 times as many bows as bracelet. So what I'm going to ask you to do is either to literally write it out or at least verbalize it in your head, 5 times as many bows as bracelets mean the number of bows is 5 times the number of bracelets. So translating that sentence says the number of bows is 5 times the number of bracelets. That's really hard for kids to understand when they write it in that weird notation, so you have to think about it in the notation you're used to. X equals 5y, so you're going to plug that in right there. This top equation for my substitution works as 4 times 5y plus 5y equals 100. So 20y plus 5y is 25y equals 100. So y equals 4. And plugging that into the substitution box here gives me x equals 20. Now remember this statement that was so weird. 5 times as many bows as bracelets. I just want to double check that we did that fine. And we did. So you'll notice at the end of the question it'll come out weird and it won't look like it's supposed to look if you don't set up this red one properly. So as far as the sentence goes, she sold 20 bows and, oops, 4 bracelets. I don't know why I'm capitalizing those. Bracelets. All right, there we go. No period, my bad. All right, so we're going to substitute here. This is more pre-calc-y. Your choice as to which variable you want to solve for to substitute in. I look for the easiest one to substitute in, so in my opinion, x would be super awesome because there's only one place you need to place the x. So x is the same thing as subtract that over 2 minus y. That's going to go right here. So my equation becomes negative 3y squared minus 12 times, instead of x, we're using 2 minus y, and then plus 3y plus 24 equals 0. All right, distribute the negative 12 plus 12y then plus 3y plus 24, and of course we have a quadratic. Why not? Which means we're probably going to get 2 solutions. So collecting all your like terms, we've got 3y, negative 3y squared, and then right here you have plus 15y. And then kind of nice, the negative 24 and positive 24 cancel, so it just equals 0. As far as solving this quadratic, I would just factor out the common term of negative 3y, leaving you with y minus 5. And if you set each of these factors equal to 0, you get y equals 0 for the first factor and y equals 5 for the second factor. So this is where it gets interesting. Your answers, and I said plural answers, need to be careful. In one of them, the y value is 0. Make sure that's in y. And in the other one, your y value is 5. And now I need you to go back to the recipe for x. The recipe for x says, oh my gosh, pen, come on. It says, right here, it's 2 minus the y value. So 2 minus 0 is 2. And then 2 minus 5 is negative 3. So either order as far as those ordered pairs go, you can flip-flop the ordered pairs, but make sure that they are paired up with the proper x and y. Fun times. If you never did your homework on that section, there's a couple of extra bonus problems at the end of this packet you should probably try. Just warning you. Alright, how do you know if you can multiply 2 matrices together? Well, remember dimensions are rows by columns. So if the columns of A equals the number of rows in B. So like for instance, if you have a 3 by 4 times a 4 by 1. If these inside dimensions match, that means yes, you can multiply them. And then for the follow-up question, what is the resultant matrix dimensions? Well, that's right here. So the result is going to be a 3 by 1. And that becomes very important when you actually have to go multiply them by hand. Now, this question is not a multiplication question. We have inventory. We started with this many. We got a shipment, so we need to add these together. So that's an easy peasy lemon squeezy question. You just add up the components. 20 plus 10 is 30. 15 plus 34 is 49. 72. And 68. And you don't have to interpret the matrix in this case. You just have to find the resulting matrix. Easy. All right, this one's worded, just be careful. I'm saying I'm going to bump up your test score by 3%. So you're going to take all of your test score, 100% of it, and you're going to add 3 extra percent to it, not points, but percent. So that means you're going to be getting 103% of your points that you accumulated. So as far as a scalar, 103% is written as 1.03. So the percentage, you have to translate that to like a scalar multiple, like a number. In other words, divide by 100, because you can't enter percentages that way on a matrix. So if you just multiply all these by 1.03, or you could enter this as a matrix and actually compute 1.03 times matrix A, you get an updated matrix. And this one's kind of weird because it doesn't tell you where to round. So I just wrote down everything. I wrote 76.22, I wrote 90.64, 65.92, and then 97.85, I think. This one doesn't tell you where to round, but the one on the test is about money, like how much should you charge for a product. So make sure you're rounding to the nearest cent on that question. Alright, this is a good old-fashioned multiply. You must multiply by hand though, because there's variables. So you circle the rows in your first matrix, and you circle the columns in the second matrix. Oh, but I should have done something before I started. This is a 2 by 2, and this is a 2 by 2. So the inside dimensions match, which means, yes, we can multiply them. And the resulting matrix is also going to be a 2 by 2. So first thing I do after I circle the rows and columns properly is I write a skeleton for my result. Alright, this is where you got to do some adding and multiplying in your head. So first row times first column. So it's 24 plus 0, so 24. And then first row, second column is 6a plus 0, so 6a. Alright, second row, first column. So 4c plus negative 16. So I will write that as 4c minus 16. And then, second row, second column, a times c plus 8 times 9 would be ac plus 72. And that's as simple as that one's going to get. Alright, this one is still on the operation, so we have to decide how we're going to enter this in the calculator and how we're going to, what operation we're going to perform. So what we have here, this matrix, I'm going to call this matrix A. It is a 1 by 3. This is matrix B. I'm going to enter it as a 3 by 3. So first I'm going to check if I have a 1 by 3 and I try to multiply it by a 3 by 3. Yes, that's going to work out fine. And then the result is going to be a 1 by 3. So I'm going to write down a 1 by 3. That's not what I meant to write down. Hello, dyslexia. Alright, so a 1 by 3 would be a long one like this. And then we think about what's going on here. So if this is your first matrix, that means you take the row from matrix A, and you're going to be multiplying the columns from matrix B. So my resultant over here, each of these columns represents the inventory value for store A, and then store B, and then store C. So you just have to be careful how you're entering these matrices and that it makes sense. So, spoiler alert, I did this on my calculator. So matrix A, matrix B, I multiplied them, and I ended up with a resulting matrix of 1151 and 2462, thank you, and 1414. And since I figured out which columns represented which, I can go fill out my answers up here. So store A has an inventory of 1151, store B has an inventory of 2462, and store C has an inventory of 1414. So the idea to this question was we were multiplying the number of calculators, or sorry, the price of each calculator times the number of each calculator that each store had separately. So we did this times this and got that number, and then this times this and got that number, and so on and so on. Now we didn't do anything, we probably typed it in our calculator. Little note to self here for my kids who are just looking at our slides, we did A times B and got that. Alright, so here, all you need to do is set up a matrix that could be reduced to row echelon form. You don't even have to solve it. So basically I'm asking you for the augmented matrix. Coefficients with the solutions. Technically you guys should be remembering to separate your body from your solutions that way for the augmented matrix. Just watch your coefficients. We're trying to line them up as best we could. And let's see, 5, 0. I always underestimate the space I need. Alright, 5, 0, negative 6, and 1, and negative 5. And then, oop, erase. Alright, 1, 8, negative 4, nothing, and 18. Alright, so that should be like a super easy question. Just read carefully. Next one, I want you to write as a multiplication matrix where you separate the coefficients from the variables from the solutions. So coefficients first would be 3, 3, 4, 2, negative 6, 4, and 4, 2, negative 4. The variables were x, y, and z in that order. And then the solutions were 30, 8, and 8 in that order. So we're just separating the three separate matrices. Now technically what you're supposed to be doing is, you're calling this matrix A and you're calling this matrix B in your calculator. And you're supposed to be applying the inverse of matrix A to the front of each side of the matrix equation here. So on your calculator, you're technically supposed to tell me you're typing A inverse times B. And it's going to pop out a 3x1 matrix that represents the solution for x, y, and z. By the way, that solution is 4, 2, and 3. However, we discussed this in class, how I don't really care how you solve the system. So as long as you know how to separate it into an equation, I'm very happy. The other thing I would need you to know is how to type the operations on your calculator. So either A inverse B, or you could have gone back and made a gigantic augmented matrix and done RREF. So that is totally up to you. All right, this question, many solutions, no solutions, all that good business. This is the one that has a singular solution. That's the easy one. So x equals 12, y equals negative 3, and z equals 5. This is the gibberish one. 0 does not equal 5, so that's a no solution. This is the one that's fun. All right, this is the many solutions. But you got to go and actually give me an ordered triple that works for this question. So like right here, this does x plus 3z equals 8. And then this one right here says y plus 2z equals 4. So when I go to write my ordered triple, I'm just going to let z be z. But x, if you solved for that, you'd subtract the 3z over. It would be 8 minus 3z, or negative 3z plus 8. And then for y, you're going to subtract the 2z over and get 4 minus 2z, or of course negative 2z plus 4. Alright, so our final topic on this summative is linear optimization. The first question, we're going to have a bounded region already drawn for you and all the vertices are identified. And then you're given a profit function as well. You need to figure out what is the maximum profit and at what point does it occur. So here's your function for profit, 4x plus 10y. And if you plug in each of the xy ordered pairs, you get 0 for this one. And then 4 times 6 plus 0 would be 24 for that one. And then 4 times 4 plus 10 times 5 is 50, so that would be, wait, did I do that right? Yes. All right, so 66 on that one. And then plugging in an 8 would be 80. So it turns out that the maximum profit that occurs for this function is $80, and it occurs at the ordered pair 0, 8. So on the following question, this time you have to create the bounded region by all the different inequalities that are given to you. So the first two just limit you to the first quadrant. We don't need to really draw that. But then your next function, negative x plus 8, that starts up at positive 8 on the y-axis, and then has a slope of down 1, right 1, all the way down to here. And I would suggest you use a ruler, oh boy, when you're graphing this, because otherwise you're going to graph crooked. And remember, we're going to have to find the vertices at some point. So your second function that you're graphing starts at positive 6 with a slope of down 1, right 2. Okay, so an important key part that I just found out, oh boy, was where they intersected. This vertex right there, that's going to be important to me in a minute. And then graphing less than all those lines will give you a bounded region that you find here in the middle, this little weird polygon. And then what I'm going to ask you to do finally is list out all of your vertices. So the dumb one at 0, 0. And then this was a vertex at 8, 0. The one where they intersected, looks like that was at 4, 4. And then the final vertex was at 0, 8. No, I'm sorry, 0, 6. I covered that up. So each one of these questions, they're all kind of their separate skill. That way if you mess up on the first part, it doesn't affect the second part. All right, this final question, I've given you some information. I need you to create a profit function, and then I need you to create all the different constraints with the variables that are given to you. So a farmer is raising pigs and geese. He wants no more than 20 animals in total, so that's a constraint right there. So if x represents the number of pigs and y represents the number of geese, that means x plus y can't be any larger than 20, so less than or equal to 20. And then the next clue says he can have no more than 12 geese. So the number of geese, which is y, has to be less than or equal to 12. And then he will spend $80 to raise a pig, $40 to raise a goose, and he has $900 to spend. So $80 for a pig, plus $12 for a goose, and he only has $900, so that total has to be less than or equal to $900. Those are the three constraints you're going to need to come up with. And then the final one talks about profit. So he makes $65 profit off of each pig and $40 profit off of each goose. So 65 times every pig plus $40 for each goose. I don't need you to actually compute anything after that, just so hopefully you're noticing that you're setting up constraints and profit functions separate from graphing bounded regions and also separate from evaluating. All right, I think that was the end of the official review. There's some follow-up questions here at the end for extra practice. If you never did your homework on this book assignment, you need to go back and do these questions because these are real nasty, and they're on your post-test coming up in a couple days as well. Good luck.